the readily available common salt, that is sodium chloride, present in seas and oceans in abundant quantity, is used for the production of various industrially important salts. The aqueous solution of sodium chloride is called as brine, which is salt water. Now, when we pass this brine into a electrolytic setup, so as you know, in the process of electrolysis, electric current is used. Electrolysis, lysis means to break. Using electric current, a compound is broken. So in this case, the compound that is being broken is sodium chloride aqueous. So brine comes in this aqueous sodium chloride, and of course we need a cathode and an anode for electrolysis, and this cathode and anode are connected to a battery which produces the current. So when current is passed, that is electricity is passed, the sodium chloride, it undergoes decomposition. So it's an example for electrolytic decomposition. So we can represent it in the form of a equation, that is sodium chloride aqueous. So it is present with water, if you have to represent the water, and when we pass electricity, the sodium chloride undergoes decomposition, so it forms ions, and there is a membrane that is separating these two. So it forms sodium ions, chlorine ions, and water will also undergo decomposition under the influence of electricity. It will produce hydrogen ions and hydroxide ions. So let us say this is the cathode, which is the negative electrode. So when electrolytic decomposition takes place, what happens is the sodium chloride that undergoes decomposition, chlorine ions being negatively charged anions, they will be deposited on the anode as chlorine gas, Cl2. So the negatively charged anion will be deposited at the anode. So chlorine gas is one of the products. The cations, that is H plus and sodium ions, will come to the cathode. So at the cathode, hydrogen gas is produced, and the sodium ions will combine with the hydroxide ions to produce sodium hydroxide. So the products that are formed are sodium hydroxide, hydrogen gas, and chlorine. Hydrogen gas is produced at the cathode, whereas chlorine gas is produced at the anode, and the sodium hydroxide is also produced near the cathode. So from the side of the cathode we can remove sodium hydroxide, which is one of the important products that is formed from the electrolysis of brine. This reaction is called as the chlor-alkali process. Chlor-alkali process is the name of the chemical reaction. Why? Very simple, because in the chemical reaction one of the product formed is chlorine. So chlor, and another product formed is sodium hydroxide, which you know is an alkali. So the name chlor-alkali process for the electrolytic decomposition of brine. And these three products have various industrial uses. For example, sodium hydroxide, as you know, is used in making soaps, detergents. It is also used to make for degreasing of metals and other important uses. So mainly soaps and detergents. Hydrogen gas, you know, hydrogen is an excellent fuel. It is also used to prepare ammonia, which is used in fertilizers. So when hydrogen reacts with nitrogen gas, we get ammonia. So which is a main component of fertilizers. So that is the use of hydrogen as fuels and as for production of ammonia, and it is also used to produce margarine. So I am writing two uses only. Chlorine, as you know, it is an excellent disinfectant. It is used in swimming pools for cleaning water, that is treatment of water. It is also used to make polyvinyl chloride, PVC. It is also used in the paper industry as bleaching agent. So these are some of the important uses of the products that are obtained from the chlor-alkali process. The products are sodium hydroxide, hydrogen and chlorine. So let us now study some important salts, how they are produced and what are their uses. So the first salt that we are going to study is bleaching powder. Bleaching powder, you know, it is commonly used for treatment of water, for cleaning the swimming pools. It is also used as a disinfectant. It is used for paper making, that is bleaching paper. So these are some of the uses of bleaching powder, and it is also an excellent oxidizing agent in industries. Chemically, bleaching powder has the formula CaOCl2, but it is much more complex than this. But for class 10 purpose, we use this chemical formula, that is CaOCl2. We can call it as calcium oxychloride. That is a scientific name, commonly called as bleaching powder. It is a yellowish salt with a smell of chlorine, with a very pungent smell, strong smell. That is what is responsible for its disinfectant action. So the uses of bleaching powder, as you know, are many, both domestically and in industries. How is this bleaching powder produced? As you can see, one of the important constituents of bleaching powder is chlorine gas. This chlorine gas is obtained from the chlor-alkali process. So you can see how important is chlor-alkali process. This chlorine gas, when it is passed through slaked lime, that is calcium hydroxide, also called as lime water. When we pass chlorine gas through slaked lime, we get bleaching powder, that is CaOCl2, and water is also we get salt and water. This is the chemical reaction involved in the formation of bleaching powder. It is calcium oxychloride. Very simple chemical reaction, important for the exam. So its physical nature is given and its uses are provided. Now, when bleaching powder is left exposed outside for a long period of time, it loses its color and it becomes whitish. When we leave the bleaching powder outside exposed, it becomes white in color, so there is a change in color. Baking soda is used in bakeries, that's why the name baking soda. So it is used to make the cake soft and fluffy. During cooking it is added. It is also added to fasten cooking to the curry or any other eatable item. So finds a very important use both at home as well as at the bakeries. Baking soda is also used in soda acid fire extinguishers, about which you have studied in class 8. Soda acid fire extinguisher, and it is an excellent antacid. So let us take them one by one. Baking soda, it is chemically sodium hydrogen carbonate or sodium bicarbonate with the chemical formula NaHCO3, and as you know, it is a basic salt. It is a mild base. How is this baking soda or sodium hydrogen carbonate produced? Sodium hydrogen carbonate is also produced from the sodium chloride. So the chemical equation is very simple. We have sodium chloride, that is the brine water, sodium chloride and water. When we pass carbon dioxide gas and ammonia gas into brine, that is sodium chloride solution, we get sodium bicarbonate, that is NaHCO3, and ammonium hydroxide. Ammonium hydroxide is also a very important industrial chemical or industrial salt. So through this reaction we get sodium hydrogen carbonate, which is commonly called as baking soda. What happens in the first case? When soda, that is baking soda, is added during cooking, we know that during cooking there is lot of heat. So under the influence of heat, sodium hydrogen carbonate, it undergoes decomposition to give you sodium carbonate, water and carbon dioxide gas. So that is the thermal decomposition. Sodium hydrogen carbonate produces sodium carbonate, water and carbon dioxide gas is given. Any carbonate containing compound will always produce carbon dioxide gas upon heating. Keep this in mind. So carbon dioxide gas is produced. So in bakery, what we use in bakeries is what is called as baking powder. Baking powder is baking soda and some mild acid, a weak acid, for example tartaric acid. So it is a complex salt, baking powder. It contains baking soda along with the mild acid, that is tartaric acid. So what is the use of this mild acid? As you can see very clearly from this equation, while cooking, when we add baking powder to the curry or in the bread, let us say, due to heat, the baking soda will undergo decomposition and it produces sodium carbonate. Sodium carbonate is bitter in taste. Okay, so this sodium carbonate, it is countered, this bitter taste is neutralized by the mild acid. So that is the function of the acid in the baking powder, which is used for cooking. So that is the first use, and this is the chemical reaction. So the weak acid will neutralize the sodium carbonate and it will remove the bitter taste. So that is the reason why there is a mild acid. That is the first equation. The second use, as you can see, it is antacid. So when there is excess acid produced in the stomach, we can use the baking soda. So baking soda can be used as antacid. It is a base. It will neutralize the excess acid, and it is a mild base. It is not a very strong base, very mild base. pH around 8 or 9. So very mild. That is baking soda and its uses. And soda acid fire extinguisher. So you know the setup of the soda acid fire extinguisher. There is a glass bottle that contains acid, let us say hydrochloric acid, and when we press the knob of the fire extinguisher, the baking soda, that is sodium bicarbonate, is released. This pressing will break the glass bottle, and the acid is now made to react with the baking soda, that is sodium bicarbonate. This reaction, that is acid plus metal bicarbonate reaction, very simple. So you get a salt, carbon dioxide and water. This carbon dioxide gas is used to extinguish fire. That is the chemical reaction behind soda acid fire extinguisher. So the acid will react. It could be sulfuric acid, it could be hydrochloric acid. It will react with the baking soda to produce carbon dioxide gas. That is about the second salt, baking soda, how it is prepared and what are its different uses with the appropriate chemical equations. The next salt we will be studying is sodium carbonate. Washing soda is chemically sodium carbonate dot 10H2O or into 10H2O. This 10H2O is the fixed number of water molecule that is attached with the salt. Different salts will have a fixed number of water molecule attached, about which we will study later. So in the case of washing soda, there are 10 molecules of water attached to the sodium carbonate. So we already know how to obtain sodium carbonate. We saw in the previous reaction, sodium carbonate is obtained by the thermal decomposition of sodium bicarbonate. So when sodium bicarbonate is heated, we get sodium carbonate. When we recrystallize this sodium carbonate, that is Na2CO3, when it undergoes recrystallization, we get what is called as washing soda, which is Na2CO3 dot 10H2O. So that is how washing soda is obtained, through the recrystallization of sodium carbonate. Washing soda, as you know, it has got variety of uses. It is used in soaps and detergents. It is used as a cleaning agent in many domestic areas. It is also used to make borax. It is used to remove permanent hardness of water. So if you have hard water, it contains calcium and magnesium salts in it. So due to hard water, the soaps and detergents will not give you enough lather. So if you want to remove this hardness of water permanently, then we add washing soda to water. For removing temporary hardness of water, boiling is sufficient. So boiling for removing temporary hardness, adding washing soda for removing permanent hardness of water. These are few uses of washing soda. The next salt is Plaster of Paris. The last salt for discussion is Plaster of Paris. Plaster of Paris is a white colored powder which finds many uses. So plaster of Paris, as you know, it is used in making toys, it is used in plastering. That is, plastering means when to make the walls smooth, so making surfaces smooth, we use plaster of Paris. It is used for decorating items, and it is also used by medicinal professionals, doctors, for so when you have a fracture, so doctors use plaster of Paris to set the bones, to hold the bones in a particular position so that it will help in faster recovery. So these are the various uses of plaster of Paris. This plaster of Paris is chemically calcium sulfate hemihydrate CSO4 dot half H2O. So calcium sulfate half, that is hemihydrate. That is the chemical name. Common name is plaster of Paris. How is it produced? Plaster of Paris. Plaster of Paris is produced from a compound called as gypsum, which has the formula calcium sulfate dot 2H2O. That is gypsum, calcium sulfate dihydrate. There are two molecules of water. So when this gypsum is heated at 373 Kelvin, this temperature is very crucial. If the temperature is more than 373 Kelvin, what will happen is we will not get plaster of Paris. So this temperature is very important. This is an example for thermal decomposition reaction, where you see a single reactant is broken down to produce two or more simple products. So with the help of heat, thermal decomposition reaction. So when we heat gypsum, we get calcium sulfate hemihydrate and additional water molecules are lost. This is what is called as plaster of Paris. If we heat it above 373 Kelvin, all the water molecules will be lost, and what you will be left with is only calcium sulfate. You will not get plaster of Paris. Therefore, this temperature is very, very important. This is the reaction for production or preparation of plaster of Paris. So the next reaction is when doctors mix plaster of Paris white powder with water and use it for setting the fractured bone, what is the reaction? So plaster of Paris, CaSO4, half H2O, white powder is mixed with water, we get the gypsum back, that is the calcium sulfate dihydrate. This is what is seen as a hard mass on the fractured part. So what we see on the hand is gypsum, which is nothing but hardened plaster of Paris, and this is the chemical reaction that is responsible for hardening of the plaster of Paris. So that is about the next salt, plaster of Paris. If you observe very carefully, when you look at this particular salt, gypsum and plaster of Paris, also other salts, example copper sulfate, ferrous sulfate, our washing soda, what we saw just now, Na2CO3 dot 10H2O. All of these salts, they are attached to water molecules. For example, if you do a simple activity of taking copper sulfate, blue crystals in a boiling tube, that's in a test tube, and heat it, after some time we observe that on the walls of the test tube there are water molecules present, and the blue color of the copper sulfate is turned into white. This is because the copper sulfate salt has lost its water of crystallization. Similarly, if you take ferrous sulfate, FeSO4.7H2O, and heat it, the green colored salt will first turn into white color and then ultimately turn into brown color. So the ferrous sulfate undergoes thermal decomposition to produce ferric oxide Fe2O3, and sulfur dioxide and sulfur trioxide gases are released along with water molecules. So these water molecules are called as water of crystallization. These are nothing but the fixed number of water molecules attached to a formula unit of a salt. So we have a salt, it has its formula, to that these are attached. Thing is, this can be easily removed by heating. So when salts lose their water of crystallization, they will lose their color, they will lose also their property, as we saw in the activity of copper sulfate and ferrous sulfate. Similarly, this also, if we heat washing soda, it will lose the water of crystallization and it will become sodium carbonate. So this water of crystallizations are the one which is providing the color and property to the salt. Similarly, in the case of plaster of Paris, we have half molecule of water attached to calcium sulfate. You may ask how half molecule is attached. It is very simple. Actually, what happens is calcium sulfate, two calcium sulfate molecules both share one molecule of water chemically. So one molecule of water is held together by two molecules of calcium sulfate, or it is shared by calcium sulfate. So for representation purpose, we say that it is half H2O and this is half H2O. So it is not that half molecule of water is attached to the calcium sulfate. So that is water of crystallization, and in this case there are 2 molecules of water of crystallization. So it is a very important concept. You can make a list of certain chemical salts like we have done in this case. So there are 5 examples here. You can also find out other salts about their water of crystallization. How many fixed number of water molecules are attached to this chemical salts, and what happens when these water molecules are lost. What is the change in color of the salts? That brings us to the conclusion of an exciting lesson, that is acids, bases and salts. Very simple lesson, very easy lesson. Thank you.